Alright everyone, welcome to your second and final lesson of Honors Math Theory this week. For the first week, you are going to have a short quiz on a little bit on quizzes, a little bit on Google Classroom. The part on quizzes is just going to be for me to make sure that you're accessing everything that you've gotten, anything that you're missing, all those sort of things, and then I'll be asking you for an independent problem for you to work through. All the rules and everything for those quizzes will be posted on those assignments on Friday. Make sure that you're checking your answers and you're posting the presentation by Friday at the end of the day. Again, if you have any questions, please make sure you're posting them. I'm recording the video a little bit in advance, so if you have questions and you're waiting for them to be responded to here, unfortunately, I'm not going to be doing that. You've got to look on Google Classroom. All right, so get yourself ready to take notes. And we're going to talk about the Cartesian product of sets. Now, it's from chapter 1, section 2. Cartesian product, it's a product. It looks like a multiplication problem. So you've got set A and set B and a multiplication sign in between them. And what this means is it's going to look like the ordered pairs. So it's going to be a bunch of ordered pairs where A is an element, where the first term is an element of A and B is an element of B. So what does that mean? It means that we're just going to create a bunch of ordered pairs when we multiply the product together. You can also have this if it was coordinate triples. You can multiply 3 sets together. That's just fine for 18, though that's not something I'm going to ask you to do because that would become very laborious to do by hand. Where our first coordinate is coming from the first set, and then our second coordinate is coming from the second. So for an example, if we have 2 sets, A is the set A, B, C, and B is the set 0 and 1, find the product of A times B. So the way I usually will organize these is I'll think about it almost like a table, where I've got my set A elements, which are A, B, and C, and we've got our set B elements, which are 0 and 1, and the product of these two, I'm just going to create the ordered pairs in this table. So for the first one, it'd be 0 and A, and I know that the A part has to come first because that's coming from the first set. So I'm going to say this is A, 0. And then the next element of the table is 1 from B and A from A. And again, I know that A comes first and then 1. And so these are the first 2 elements of our product. And then I can just finish filling in the table. So this would be B0, B1, C0, and C1. If you want to write it all out as one very long list, you can. That's what the book will do in the back, but that's just a nice way to organize it. So all of these together, if you wanted to make a list, put the brackets in, commas, is the set A times B. Now, one thing you'll notice is unlike most multiplication you've seen up till now, is the Cartesian product a commutative operation? No. Right? AB is not the same as BA unless A is equal to B. So if the 2 sets are the same, so A times A, sure, then it's commutative, but otherwise no. Remember that commutative means that order doesn't matter, that A times B would be the same as B times A, which is not true for sets. So the next thing we're going to be talking about is the cardinality of a set product. Remember, cardinality means the number of elements in a set, and in this case, in a product. There's a nice rule of thumb, if you'll notice here. We had 3 elements in A, 2 in B, and then we had 1, 2, 3, 4, 5, 6. And that absolutely works as a metric for finite sets. So if we're doing finite sets, the cardinality of the product is equal to the cardinality of the 2 multiplied together. For infinite sets, things get a little bit more complicated. We will talk about the cardinality of infinite sets later on in this course. So here a question might be, find the cardinality of A times B times C. As I mentioned earlier, it's just fine to have 3, 4, 5 sets multiplied together. The same rules continue to apply. This would just be ordered triples. So find that given that the cardinality of A is 4, cardinality of B is 2, and C is equal to 0, 1, 2, 3, 4, ... which might make us worry about infinite, but it ends at 10. So we can extrapolate from this rule for finite sets that the cardinality of A times B times C is equal to cardinality of A times cardinality of B times the cardinality of C. Now the nice thing is that A and B were already given. 4 times 2. Cardinality of C, we're given the finite list here, so you have to use a little bit of logic. There are 11 elements in C because we have 1, 2, 3, 4 up to 10, so that's 10 elements, and then plus we also have 0. So cardinality of C is 11, meaning that the cardinality of A times B times C altogether is 88 ordered triples. All right, you've actually seen multiplied products of sets before. We're going to talk about the coordinate plane. So if I'm looking at this first one, which is the real numbers times the real numbers, right? We're looking at the coordinate plane, so these are our x values, and that's all of them because it's the real numbers. And then we also have our y values, which is all of them. And that's exactly what it means. So we've got all of the y values, all of the x values, and this creates the coordinate points in between. So r times r is in fact the entire coordinate plane. You'll even sometimes come across this idea that the coordinate plane will be called like the real number squared, or r squared with this extra line, in textbooks, because that's what it's referring to. It's all x values, all y values. So you'll see this in several advanced math textbooks. And it's you can use the exponent just like we would here. This is r times r. Anything times itself can be written with an exponent. We also might have r times n. In this case, we have our x values, which is all of them. Any x value is just fine here. But our y values are only the natural numbers. So if I'm looking here, my y values are just the positive natural numbers. So these are my y values. And unfortunately, I can't put a finer point on the stylus. So if these are the only y values available to me, but I can have any x values, this set is going to be these long lines that line up with the y natural numbers, because the y coordinates can only be 7 or 2 or 3, but it can be any x value we like. So it could be negative 236 over 7 as the x coordinate, but the y coordinate is still only going to be 1. So you've got this vertical stripe. Please put any comments or questions that you have in here or in an email. Thankfully, this video is significantly shorter, but if you're confused about anything, please ask. Please nominate any questions you're stuck on or ask about them in a one-on-one meeting, and I look forward to talking with you all later. Have a good day.